All right, so our last section of Unit 5 is graphing radical functions, and I promise radical functions are a lot easier to graph than rational functions because we really just have two forms. We have our square root function and our cube root function, both which you can see below. A radical function is just a function whose rule is a radical expression. All right. And radical functions, they are the inverse of quadratic. A square root function is the inverse of a quadratic. A cube root function is the inverse of a cubic. And then a fourth root, quartic, and so on and so forth. All right. So let's start with our two most basic radical functions, square root function and cube root function. And these are really just the two you're going to be responsible for knowing how to graph, cube root and square root. All right. So let's go ahead and make our input-output table here. And we're going to plug in some values. We need to keep in mind for a square root function, we can't take the square root of a negative. So we're going to have to start at 0 and then start listing out our perfect squares, our positive perfect squares. So 1 is a perfect square, 4, 9. You could use other numbers like 3, 6. Those aren't perfect squares, so you'd have to punch those into your calculator instead. These give us nice, easy outputs. So 0, the square root of 1 is 1. Square root of 4 is 2, and square root of 9 is 3. So we can go graph this right here. 0, 0, 1, 1, 4, 2, 9, 3. Hopefully you see this graph kind of looks like half of a parabola, just without our negative x values because we can't take a square root of a negative. Let's list our domain and range. Domain is all real numbers that are greater than or equal to 0. And our range happens to be the same thing. All of our y's that are greater than or equal to 0. Okay. Cube root. Cube root, we can take the cube root of a negative, right? A negative times itself 3 times will get you a negative. So we're going to have some negative values in here. And then let's start thinking of some of our smaller perfect cubes. So negative 8 is a perfect cube, negative 1, 0, 1, and 8. Our next perfect cube would be 27, which is going to be off our graph, so we're just good with these 5 points. The cube root of negative 8 is negative 2. Negative 1 is negative 1, 0, 1, and 2. So let's go graph these points. 1, 2, 3, 4, 5, 6, 7, and 8. Negative 2. Negative 1, negative 1, 0, 0, 1, 1, and 8, 2. So if you remember graphing cubic functions, a cube root function kind of looks like a cubic function just turned on its side, right? Okay, we can take those parent functions, domain and range. Domain for a cube root function, as you saw up above in our table, we can input any value. Domain is all real numbers, range is all real numbers. We can take those parent functions and transform them, right? So our transformation form would be f of x equals a times the square root of b. You know what? We're going to write it as 1 over b to remind you it's the reciprocal when we're describing it for those horizontal stretches and compressions. Let's define each of these. A, B, H, and K when we're transforming these. K is your shift, and let's make sure that it's really outside. That K should not be underneath your radical, so we'll put it all the way down here, outside your radical. K is your shift up and down, vertical shift. H is your horizontal shift. You've seen these values before. A is your vertical stretch or compression. And B is our horizontal stretch or compression. And I wrote it as 1 over B to remind you when we're describing the horizontal stretch or compression, you describe it as the reciprocal. And you'll have an example like that down here below. Let's go ahead, and the way we're going to graph these is we're just going to use these shifts, the horizontal shift and the vertical shift, to plot our new x and y axes, and then we're going to plot and graph these using these parent function tables. Okay, the way we've graphed transformation form before. So this would be a shift left 3, up 3, and this would be a vertical, remember if it's less than 1, vertical compression by a factor of 1/2. So left 3 would move us over here, up 3 over here. Our vertex is going to be where those shifts meet. And then our parent function values 0, 0, 1, 1, 4, 4, 2, and 9, 3. We would now just be multiplying all of our y's by 1/2 because we were horizontally compressed by a factor of 1/2. So this would get us 1/2, 1, and 3 over 2. So 1, 1/2, 4, 1, and then 9, which should be over here at 6, 3 over 2 or 1.5, and you can see that's been horizontally compressed by a factor of 1/2. All right, let's try another. Let's try 4, and then you can graph 5 and 6 on your own. For 4, we don't have a shift left or right at all. We just have a shift down 2. And be careful, these are not asymptotes. I know I graphed dotted lines for rational functions as asymptotes. These are our shifts. So we're always going to have a point at where those shifts meet. So we only shifted down, so we're still going to be on our y-axis. And then now we're going to take these points, copy and paste them, and we are going to apply one transformation here. This negative inside, that's a reflection. If you remember, if it's a negative b value, it's a reflection over the y-axis, which means all of the x's are going to become the opposite. So times -1. So we get 8, 1, still 0. We have that point right here. -1, -8. And we can go graph. 8, 2 would be right here. My apologies. 8, -2 would be right here. 8, -2. 1, -1. -1, +1, and -8. +2. And there's our graph. Hopefully you can see, similar to this function right here, however, we just reflected over the y-axis. Okay, that's what that negative inside did. And we also shifted down too. Okay, so use these parent functions as a reference. You can just have them plotted on Desmos if you want, to really make sure that you're graphing these correctly. Okay, 5 and 6 on your own, and then I want to finish up with 7 and 8 together because those have, well, definitely 7. 7 has that horizontal stretch or compression that I'd like to do together. All right, 5 and 6 on your own, go ahead. For 5, we were shifted to the right one, and then our table of values, all of our y's are going to be multiplied by -3. So it's going to be a vertical stretch by a factor of 3 and a reflection over the y-axis. So 0, 1, 4, 9, 0, 1, 2, 3. These were all multiplied by -3. We can skip 0 because that's just 0. So our starting point would be here. 1, -3 here. 4, -6. Sorry. 1, 2, 3, 4, -6 down here. And our graph would look something like this. So you can clearly see it's been stretched vertically, and it's been reflected over the y-axis. For number 6, this was a shift left 4. It wasn't a shift up or down at all, so our starting point would be right here. And then we multiplied all of the y's by, or all of the y's would need to be multiplied by 4, because that was a vertical stretch of 4. So times 4 times 4 get us 8, 4, -4, and 8. We already have our 0, 0, so -8, +8. Way up here, sorry, I'm a little off my graph. -1, +4, 1, 4. Oh, I'm sorry, those should be down below. -1, -4. There we go. Let's fix those points. +1, +4, and +8. +8. All right, so we have something like this. Very, very steep vertical stretch because we are multiplying by 4. All right? Okay, let's finish up 7 together. So 7 has a couple transformations here. We've definitely been shifted up 2, right? Got +2 at the end. It means we can put our starting point right here. We've been shifted up 2, and that's it. This negative in front, that's going to be our reflection over the y-axis. So all of the y's, reflection over x. So all of the y coordinates are going to become the opposite. And then remember, this is always the reciprocal, and when it's greater than 1, it's a horizontal compression. Hopefully you remember these from quadratics. Horizontal compression by a factor of 1/3. So for our table with 0, 0, 1, 1, 4, 2, and 9, 3 are parent function values. All of the y's need to be multiplied by 1/3, and all of the x's need to be multiplied by -1 times -1 times -1. So we can skip 0 each time. So now we have 1/3, 4/3, 3, -1, -2, and -3. Okay, 0, 0 is taken care of. We already have that point on there. 1/3 and -1 would be right here. 4/3, -2, right here. And 3, -3 down here. Okay, so horizontal compression is going to look similar to a vertical stretch, which you kind of have here. You can see it a little bit, not as much because it's not a big factor, but we're also opening down as well. All right, let's have you try one more as well on your own. Try 8. It's a cubic function. You have 3 transformations. Go ahead and we'll check your work when you're done. Okay, we should have shifted down 5. So our new starting point down here is going to be our vertex. And then all of the y coordinates needed to be multiplied by -2. So a vertical stretch by a factor of 2, and a reflection over the x-axis. Okay, so let's go ahead and plot those points, -8, +4. -1, +2, 1, -2, and 8, -4. Let me head something like this. Okay, all graphing. No homework on this section for tonight, but you should still expect radical function graphs to be on your final. Just keep in mind, I'm probably not going to ask you to graph these. I would just ask you primarily to describe the transformations, right? So make sure you're comfortable describing the transformations. There might be one where I ask you to graph. All right, plenty of examples on the final review packet, and I can answer questions during our flex day.